Welcome to this special edition of Frequency Matters. I'm Gary Lerude from Microwave Journal, and I'm here with Bryan Goldstein, who's the General Manager of the Aerospace and Defense Business Unit at Analog Devices. Bryan, thanks for joining us.
Well, thank you, Gary.
Why don't you tell us a little bit about your background and what led you to the current role that you're in?
Sure. I actually started my career at Raytheon, and I was involved in the Patriot missile program, and I was actually involved in the early days of automotive radar, believe it or not. And from Raytheon, I went to Sanders, a Lockheed Martin company, which is now BAE Systems in Nashua. And I got involved in the Longbow missile program and got very involved in, again, at Ka-band, high power amplifiers and receivers. In the early 2000s, did a stint in the commercial world at Arcom Wireless doing microwave transceivers modules for the point-to-point radio market. And in early 2000s, when that market took a bit of a dip, I moved on to Hittite Microwave and got involved in very early days of their module and subsystem business. When we got there, it was a very, very small piece of their business, but we grew it significantly. And I held roles in engineering. I've also held roles in manufacturing. I've run manufacturing lines. I've been involved in program management, and ultimately I became vice president at Hittite in their module, subsystem, and space business. And 2 years ago, when Analog Devices bought Hittite, I got the role of general manager of the Aerospace and Defense business.
I see. A lot of people come through Raytheon.
Oh, a lot of people, and I'm working with a lot of the same fellows that I've been working with for the last 25 years.
Yeah.
It's a very small microwave industry for sure.
Bryan, from your position, as you look at the aerospace and defense market, what trends are you seeing, and how is Analog Devices positioning to address those?
As you know, in the aerospace and defense market, trends always start with size, weight, and power. Smaller platforms like UAVs, handheld radios, microsatellites all require smaller, lighter systems that require less battery power. New requirements that we're seeing include modular, configurable, cognitive systems. New systems are required to get to market faster. The money that's available for investment is smaller. So modular systems are being developed so that they could be reused from system to system over time. We can get to market faster. We can reuse these systems in multiple platforms. Software-defined systems that are cognitive and reconfigurable. For example, software-defined radios that self-sense interference signals, can self-avoid, can move the frequency, can change the modulation scheme in the face of interference. Another example of radar systems that can cover multiple frequency bands and multiple applications. Imagine radar systems that can do tracking, can do mapping, can do electronic surveillance and countermeasures, communications, reconfigurable, programmable, changing the frequency band, changing the modulation schemes, being able to do all of these different applications all simultaneously.
Right. How is Analog Devices positioning to address these trends you've just described?
We're attacking it in many ways. Again, it starts at the semiconductor level. We're designing on smaller nodes in silicon. For instance, 28 nanometer is allowing us to go higher in frequency and dramatically reduce power consumption and reduce costs associated with integrated RF microwave functionality. Size weight reduction through multiple levels of integration, starting at the die level, where we're able to combine now RF, analog, and digital functionality on silicon. Heterogeneous die, where we're able to integrate multiple flavors of silicon, gas, and Gann onto a single substrate, and then ultimately leading to a system in a package, component level packaging, as well as complete integrated modules and subsystems. Multifunction cognitive systems are dependent on high-speed converters, and our integration of the high-speed converters with our full RF microwave portfolio is allowing us to do some interesting levels of integration at the chip level, as shown in our new Radioverse transceiver product family, which enables programmable, adaptable systems in extremely small form factors. And then ultimately, our ability at the system level to integrate the components into larger, higher levels of assembly are forming partnership relationships with our customers because they're seeing that we add more than component level expertise. We now offer system level expertise, and the ability to design and manufacture these higher levels of integration is something that's a real differentiator for us.
So you mentioned the Hittite acquisition 2 years ago, and I remember at the time the tagline being bits to antenna, and you've touched a little bit on it here. Could you talk more about how in your business unit you're going from bits to antenna?
Sure. Just having the complete portfolio of products that go into a radar, EW, or MILCOM system is interesting enough on its own. But the fact is we now have system level knowledge where we're sharing that with our customers, and we've become more than just a supplier, we've actually become a partner in our customers' journey. And now we offer complete solutions, again, that allow them to minimize size, weight, and power and time to market. We're bringing cutting-edge technologies that cross multiple pieces of their platforms. For instance, sensor fusion is something that we're hearing more and more about. I'll give you an example. In small UAVs or guided munitions, customers are using our MEMS-based inertial measurement units for stabilization and guidance. They're using our RF components for their RF seeker target tracking and weather tracking. They're using our data link components for their communication aspects in these systems. And to be able to minimize the size of these, we're able to bring those 3 different subsystems together and integrate at a system level for our customers in these very, very size restrictive applications.
Interesting. So all those pieces allow you to basically move up the food chain.
Typically, our customers would have to work with 3 different suppliers, and being able to combine those things was nearly impossible. And now that we have all the pieces, we're able to offer a solution that combines these technologies that nobody else can provide.
Interesting. Let's talk a little bit about Gann. I was impressed at the International Microwave Symposium, which we just completed a few weeks ago. The fact that Gann seems to be crossing the threshold into the commercial markets, principally the wireless infrastructure side. But of course, it's been playing for years, and the motivation for developing it came out of the defense market. And I think you were an early adopter in terms of using Gann. Can you talk a little bit more about how you're using the technology and what kind of applications you're inserting it into?
Absolutely. We're very, very heavily involved again at both the semiconductor level and at the module level. Power densities that can now be achieved are a real game changer in the industry. The volume of devices that are used in phased array application and the high number of devices that can be combined to create very high power levels to replace TWTs and magnetrons have gotten the volume of Gann up to a point that it's very, very interesting, and ultimately the price will get to a point where the commercial markets are able to adopt it more readily as well. Working in both Gann on silicon carbide, where we can get the optimum performance, and Gann on silicon, where we can get the cost down and do some higher levels of integration, are both areas of interest for us. Imagine, if you will, where you could combine your high-speed converter technologies with your RF microwave, with your high-power amplifiers, and all the biasing circuitry that goes around the Gann and the linearization that goes around the Gann, all on a single piece of silicon. You could start to imagine phased array radars. You could imagine EW systems all on a single wafer of silicon. So this is very interesting to DARPA. It's very interesting to Analog Devices, who is going to help them get there. Currently in Gann, we're filling out our Gann component portfolio at the semiconductor level. And in parallel, we have a number of interesting products that we're doing at the module level. Just this year, we've developed a 2 to 18 gigahertz 100-watt power amplifier module, as well as an 8 kilowatt X-band power amplifier module. The 2 to 18, of course, being for EW and test equipment application, and the X-band being for either weather or military tracking weather applications. As far as our roadmap, we will continue to fill the portfolio and go to wider bandwidths, higher power levels, and higher frequencies, and ultimately into Ka band and W band and beyond.
Right. It's amazing what the technology has done. One of my early assignments in my career was doing a 6 to 18 gigahertz 1-watt power amplifier, and we thought it couldn't be done. And now you're talking about 100 watts, 2 to 18.
It's absolutely, the market and the technology has moved very, very quickly over the years. Where have the years gone?
Yeah. So you mentioned phased array. Certainly the phased array architecture, the active phased array, has been a dramatic change in radar systems over the last 20 or 30 years. And I assume that's a market opportunity for Analog Devices going forward?
Absolutely. Our breadth of portfolio is having a major impact in the direction that technology is going. As you know, the new architectures are driven around the high-speed converters and transceiver technologies. Right. And our silicon technologies are really driving the simplification of these architectures, and combine that with our RF microwave in the area of beamforming core chips, in the area of Gann transmit receive functionality, and you can see how we're going to help revolutionize the phased array technology in the not too distant future. This market was once dominated by the tier 1 defense companies, right, and this technology was very, very expensive. Mm-hmm. But with the advent of the integrated silicon, the high-speed converters, our integrated transceiver chips, we're able to really drive down the cost and really simplify the architectures. You can basically put a high-speed converter at every element of the array, and our customers are able to envision themselves doing some very, very interesting things in both the military and civil applications. It's an area where the commercial world, in terms of automotive radar, has helped drive down some of the silicon costs. The right. military has developed the Gann, and together there's been a real interesting synergy between our commercial work and our military work, helping both sides advance the technology. The work that's being done in 5G is absolutely paralleling the work that we're doing mm-hmm. in military and civilian radar.
Well, this seems like a really fascinating time to be involved in the defense market, and it's going to be quite disruptive over the next decade or so, and you and your team are right in the sweet spot of it.
Absolutely. We see the government spending their money on advancing the state-of-the-art of the electronics pieces of their military portfolios, and we're absolutely right in the middle of it, starting at the components, moving to the system level applications, and then ultimately being a complete solution provider.
Well, Bryan, thank you for coming by the studio and spending some time with us and giving us a view into that future.
Oh, thank you very much. Also, I wanted to mention that Analog Devices will be participating at the EDI Con,
yes,
September 20th to the 22nd. So please stop by our booth.
Definitely, and we hope you'll send some engineers to enjoy it as well.
Absolutely.
Great. Thanks, Bryan.
Thank you.